Everyone. In this video, we will talk about AWS Elastic Container Service. To start with, log into your AWS account and search for ECS. You will find Elastic Container Service, which is a AWS managed service to deploy any Dockerized application. It is highly secure, reliable, and scalable to run any containers. So just click on this service, and then you will see that there is an option of create a cluster. So that is the first component of Elastic Container Service, which is a cluster. So to create any cluster, you will click on create cluster, name of the cluster. So generally the best practice says that you create different clusters for each of the environment. So like if your application is app 1, then just put like this. So this just helps you and separate all the configurations according to the environments also. So this is like best practice to just go with the environment's name in your cluster name. And then infrastructure. So ECS provides two capabilities: serverless, which is AWS Fargate, where you just pay as you go, and it is good with your tiny and small workloads, and there is no maintenance with AWS Fargate. And the second option, you have Amazon EC2 instance, where you will create an EC2 instances and manage those and use those to deploy your workloads. In this particular example, we will go with AWS Fargate. Monitoring. So this is an option to enable the monitoring. So by default, the container insights are disabled. So I would recommend to enable this monitoring. That will provide you the metrics at the cluster and the service level, so that you can actually analyze or metrics to just check if there are any issues. That will just give you all the information about your ECS cluster. The encryption, you have an option to use the encryption also for any managed storage. In this particular video, we are just skipping this. And tags is always a great idea to put it. That will help you to identify all the resources which are tagged for this particular environments. And in big organizations, we have a proper component IDs, and the this particular service is belongs to this particular team. So this is beneficial to use tags whenever you can. So just click on create cluster. So when you click on this, it is creating the cluster called app-dev. And here you can see that internally ECS has a cloud formation template which is actually running, and here you can see that it is creating it. So this is like, because AWS is a managed service, you have to just click on this button and set up your cluster. And at the background, some cloud formation task is running and it is creating a cluster. So here you can see that your cluster is created. It is still in progress. Once it is created successfully, you should be able to see all the details here, like container insights also, because we have enabled it. So now the next option, once you create a cluster, here you will see all the cluster details whichever we have configured while choosing the option. And under that you will see that we have services, task, infrastructure, matrix, schedule task. This is like a schedule task, and the tags also. Now we will learn how we can run a standalone task on the ECS cluster. So to run any task, first we need a Docker image. So for that you can go to Elastic Container Registry. So this is a fully managed Docker container registry that you can use to push any of your Docker image there. And in that you have an option called private registry, where people will not have access and you need to provide the specific access to your private registry. And the second option, you have public registry. So in this particular example, I will be using public registry, and here you can see that I have few demo services that I have already pushed the code there. So this is like one of the example of hello service which is pushed, and this is my URL to use this particular service. So this is like the ECR, which is an AWS managed service to uh, Elastic Container Registry service to store your Docker images. So first thing you need this. The second, you need IAM roles. So whenever you are running uh, any ECS task, it needs an IAM role also. So I have created this ECS task execution role. And here you can see that I have a permission Amazon ECS task execution role policy, which is AWS managed policy that you can use directly, and it has all the permissions, basic permissions that your ECS task needs. Like first, your ECS task needs to pull the image from ECR. So these permissions are for those things. And the second, log. To create any log groups and any logs in the CloudWatch log groups, you need this particular permission. So this is the basic permission. If we have a more requirements, you can always assign more policy to your IAM role based on the requirements. And here you can see the trust policy is ECS task, because we are running the ECS task inside a container. So this is our trust relationship. These are the two major things that you need to run any standalone task on the ECS container service. So, and here you can see now we have the Docker image, we have the IAM roles. What is the next step? So this is like task definitions. So for any application, you have to create the task definition first. So like if I just go to this example of task definition and how it looks like, here you can see, let me just go with this create new revision. And so this task definition will contain all your application details. Like first it will have the Docker image, where you want to run this Docker image, and second, your task size, like what is the requirement for your application. So you define CPU and memory details over there. Based on that, whenever your task launch, it uses this configuration. So this is where you can see all the options, all the predefined options that AWS provides. So when you are using the Fargate, you really don't have any option to customize these arguments or in these parameters. If like suppose if I want to use one CPU, I do not have option to use 0.5 GB memory. I have to go with 2 GB only. So this is like some predefined memory CPU combinations that AWS already has created it, and you can use those. So in most cases, it will solve your purpose, but yes, there could be some scenarios where unnecessary you may be paying more because you don't have any custom options and you have to use the one which AWS provides. And now here you can see the task role. So I have defined this ECS task execution role and assign it here. And then you have the container details. So this is where you provide the name of your container, and this is the image. So this is our ECR image. You can even use the Docker Hub image also, but in this example I'm using ECR. And as I told you, if you are using the private registry, then you have to have the authentication also, so that option is also there. And here we are putting the container port mapping. So this is just like your container port, and by default you provide this protocol and your name of the port name. So this is port mappings that allow the container to access ports on the host to send or receive traffic. If you don't have any port mapping configurations, your load balancer will not work when we work into the ECS service and do more configuration. So this is the reason we use the container port. And then we have lot of other options like environment variables. So whenever we run any Docker container, you must have seen that we provide some environment variables also. It could be anything, any variable files or any kind of environment variables that you might need to pass. So this is how you can actually pass it, add key and your value type, value and value from, and then value. This is the environment variables you can pass, and even you can use the environment file also. In this example, this is a very simple example, so I'm not using any values. And then you have a log collection. So I'm using the AWS native CloudWatch, and here you can see that now we have lot of options for the logs also. But in this example, I'm using Amazon CloudWatch, and this is like AWS log group. So it will create in the CloudWatch, you will see that this log group is created. You provide the region, and your AWS log stream prefix is also ECS. So when we will launch the task, I will show you how it will look like into the CloudWatch. And this is all customization. You can change it according to your requirement also. Other than that, I'm not changing anything. All are default configuration in this task definition. So now once you have the task definition created, you can go to your cluster. So this is the cluster that we have created, and click on task and run new task. So basically this is a standalone task that that will just run your application, that will just run a standalone container. So here you can see that you are providing this capacity providers. So now we have an option even to go with Fargate Spot, but now I'm just going with the Fargate, your platform version and application type. So this is like a standalone task, and this is mostly used for the batch jobs, like you want to schedule some task to run particularly on Sunday. So you just start the task. That's it. You don't need to have to go with this particular configuration. That we will talk in the next lecture. But for now, this is task we are creating. And here you will get all the task definition which we have created so far. So I will be selecting this hello service, and you can just select the revision which you want. So I will go with the first revision, or you can go with any of them. And the desired task. So here you will specify number of tasks to launch. So we can have one, we can have two, we can have three. So based on your requirements, you can run number of containers you want for your application. So for this, I'm just going with the one. And in the networking, so basically you provide the VPC details. So I have this VPC. So this is also the prerequisite. You should have the VPC because you want this container to run somewhere. And in the subnet, so I'm going with the public subnets as of right now, but generally we always run our applications inside a private subnet and access it using the load balancer. We will talk about all those details into the ECS service section, but for now I am just using the public subnet. And then use an existing security group. So you need a security group to, so I'm just using this so that you can access this particular task once it's launched. So based on the security group access, you should be able to access this public IP on the internet if our security group is defined properly. So I can just show you how this is right now. So if I go to EC2, and here you will go to the security groups, and we have this ECS service security group, and we can just check the permission. So here you can see that I have permission all traffic right now from anywhere. So I have all, like, you just go there, yes, all traffic. So you can actually customize it like TCP. We just need port 80 and custom from anywhere. So this is the place where you can define if you have some VPN. So you can just assign the IP of that VPN, and if you just want it to be routed only from the inside VPC, you can have the CIDR block of the VPC also. In this particular example, I'm going with the public one, so it is accessible from anywhere. So now I'll just go there, use an existing, and here you can see we are just assigning the public IP for your task so that we can access it and test it. You have an option to create volume also, but for now we don't need any additional storage, and we'll just go with the create option now. So let me just click on create here. So now you can see that we have the task running here. So let me just go there. So here you can see the task, it is provisioning. So here you can see that it is going in the pending. It will take a little bit of time before it comes up. But this is how in the task you will see when you run a new task, and it will provide you the task definition which it is using right now. And here you can see that now its status is in running. So you can go to your task, and this is all the configurations. You will find it here. Like you can see the CPU memory, the platform version, whatever you have put in the task definition. And because we have opted for the public IP, here you can see that I have this public IP. So now if I go to this public IP, I should be able to access it if I have all the options, if I have security groups updated properly. So here you can see that I got this particular page because my application is configured in this way that if I put slash hello, I will get hello from hello service. So this is how you can see that one standalone task is running, and you can access it using public IP. You really don't need to assign it to the public IP if you don't have any access requirements, or if you don't want to access it anywhere else. You can just run it in the private subnet also. And here you can see that you should be able to see all the logs also like this. And now if I go to CloudWatch, so how it looks like in the CloudWatch. So as I told you, in the CloudWatch, we have created this log group with the name ECS Hello Service. So this is how it's created. And now under that, you should be able to see your task. So this is your task ID that is running right now, so that you can see the log. And this is how your basically this is just a Tomcat application, and this is how you can see all the logs for your application. So now if something happened to your task, it crashes or anything happens, it will be stopped. Your application will be down and it won't be accessible because of any reason. Like if I just click on stop right now, it just stopped because we have just created this standalone task. As soon as you click on stop, it is stopped. I just take an example. It could be stopped by any application crashes also. But once it's stopped, it's stopped. There is no auto failover or there is no auto recovery of this standalone task. So, but this is the simplest way of running any task on the ECS cluster, which is helpful for deploying for any batch jobs or for any scheduled jobs that you just want to run it for few hours or few minutes and then just stop or just kill those tasks and launch the new task another day. This is the basic use case for the ECS task. Okay. So now we will learn about ECS services. So we have explored the option of a standalone task. Now we will see what is ECS services. So for the ECS services, you'll go there and click on create. So the ECS service basically, if you click on this info, you can see you can deploy long running stateless applications, and you can also choose how many instances you need to run for your application. And if any of the tasks fail that I showed you, the service scheduler will automatically try to fix that issue and start the another task and replace the failed one. So that ECS, so basically the ECS service is maintaining your desired number of tasks also. And when you create the ECS service, you have an option to go with the ALB also. But in this example, we'll just go with the simple creating a service. So here you can see that I have created this cluster, capacity providers, and now in application type, I am selecting the option of service, and I'm going with the hello service. And in the service replica, I'll just go with the replica and the desired task. So here you can have the option of two or three or four, how many tasks you want to run. Deployment options. So we have two options, rolling update and blue green deployment. So we are going with the rolling update, which means whenever, based on this configurations min and max, it will ensure that your application is available during the time of deployment. So when you specify as minimum running task 100%, it means when it is doing the deployment or it is a force new deployment, always your desired task is running and it will be launching the new instance first before killing the existing one. So this minimum and maximum you can configure it based on your requirements, like how many minimum number of tasks you want to run during updates and how many maximum number of tasks can run during the updates. So in Fargate, it's fine. You can have this configurations. In EC2 you just need to specify based on your capacity, because Fargate is serverless. We don't need to worry about if it is launching 10 instances at the time of deployment, because you have a desired task as 5. So it basically, this is how you can do the configuration. We will not go with any of these options right now. In the networking, again, we'll just select the VPC and the subnets. I'm going with the private public. I'm going with the public one because so that I can show you how I'm accessing the URL. Otherwise, if you go to the private subnets, you have to launch the EC2 instance in the private subnet and then do the curl URL and then validate the result. Or if you have a VPN configured on your system, then you can go with that approach. But to make it simple, I'm going with the public one. And the security group, I'm again going with the simple ECS service security group, and this is the public IP. The load balancing option, I'm not selecting that option right now. I'll just click on this create. Oh, we didn't put the service name, so hello service. Okay, so now here you can see that your service is being created, and you will see all the details here. And here you can see that two tasks it's trying to launch, and here you can see all the details of your sub service. And if I go to service and click on task, you will see that it is provisioning. And if I go to any desired states, you will see it. So this is how the service works. You create the service and then you can define how many tasks you want. And just some tabs like in the events, here you will see that all the events related to your service will come there, that it has started one task. Once it is started successfully, you will find all the events related to your deployment here. In case it failed, you will get that information also. And here you can see that it is still running. Both of them ran successfully. We can check that. So if you go to the public IP again, and I just open it, and as I showed you, this is working. Hello from hello service. So this is how your ECS service works. Now in this, like if something happened, your service got crash or anything happens, container crash, then what will happen? So it is automatically try to launch the new container and replace the failed one. So here I don't, so what I will do, I will just stop the task manually. So like it could be stopped because of any reason, but I'm just stopping it manually. So I'm just selecting and click on stop. So what will happen now? Now you will see that the another task started running because you have a desired state. You have a desired state of 2. So if because of any reason your task is stopped or killed, it will try to be on that particular state again. Like if it has a 2, it will go back to 2. So that is the basic advantage of services, and that's why the people uses services over task, because it is take care of all your configuration and ensure that your desired configuration is always running. So this is how it is. Now I wanted to show you the example of force new deployment. We will do it. So we have a desired task 2. So this is, you can say that we are having a deployment now. So what will happen? So based on your this configuration, your deployment will happen. So in this particular scenario, it will not kill the existing task. First, it will launch the two new tasks. Once those are running, then it will try to deprovisioning those. So this ensures that you have a rolling update also, and this is also ensuring that your application availability has not impacted because of the deployment, because it is first creating the new instance before terminating the existing one. So let's just do this configuration real quick. Click on update. Okay, so now where we will go here, and now you will see, let's go there. Okay, so now you can see that it has started the one provisioning, it is doing the provisioning, right? But these two are still running because of our configuration. Okay, so now you can see that all of your four tasks are running. It just started both of the new task, and now if I refresh it, it will take little bit of time before it actually terminates the existing one. And those things also you can validate in the deployment section, that deployment status is still in progress. It has not completed it. Here you can see that it is still in progress. And here, as I have showed you the event, here you will see all the events related to your deployment. So now let's see if it has killed the task already or not. Okay, so now you can see that you only have two tasks running, which is our desired state, and other than that, everything is stopped. Only two are running right now. So this is ECS service you can run and provide your configuration. So in this, you are always accessing your application using the public IP. So and now you have created the ECS service and you really wanted to access your application. How you will access that? You cannot provide the public IPs or even the private IPs to any of them who wants to access your application. So to access your applications, you need ALB, which is application load balancer, so that that particular load balancer you can actually use directly or have a Route 53 configuration that will point to your load balancer. And the reason why you cannot even use the public IP, because whenever you start the instance, your IP is getting changed. So these IPs are not reliable or are not constant. So because of that reason, you have to use the ALB to access your application. So for that, first we need a load balancer. We need to create a load balancer. And a load balancer, at very first step, it needs a target groups. Target groups are used in context of load balancer, and it is associated with the load balancer and route the traffic. And we assign all our instances or IPs or Fargate IPs, everything into these target groups, and these target groups route the request to the load balancer. So here you can see that how you can create any target group. So if you click on create target group, you will see a lot of options. So one is instance, where you can actually provide your instance details, like EC2 instances or anything, and the IP addresses, where you can provide the IP addresses, Lambda functions, application load balancer. In this particular example, we will go with the IP addresses. And here you can put the name of your target group. So I'm going with the hello target group, and the port is 80 because my application is also running on 80. So we are not changing anything there. VPC, we need to select the VPC which we are using. And I'm going to use this HTTP1 protocol version. And here you can provide the health check configuration. So my URL is actually slash hello, as you have seen in my old examples. So I'm going with slash hello and health check settings. I'm going with the default right now, but this is here you can define healthy threshold, your unhealthy threshold, like for consecutive when it should consider your instance is unhealthy. So based on all these threshold, your instance will be healthy or unhealthy, and how frequently you want to check it, like the interval, the timeout, all those configurations you can provide in this health check. And this is the success code. So we'll go ahead and click on create, and then you are providing the, this is the choose network specific IPs. We don't have any other specific requirement, so we'll just remove it and just click on create. Okay, so we have this load balancer created, but here you can see that we don't have any load balancer associated with it. So next step we have is we will go to load balancer and click on load balancers. Here you will have couple of options. In this particular example, we will go with application load balancer, which is a flexible feature for your applications with HTTP and HTTPS traffic. So click on create, and here we can just put the name of your of your load balancer, and the internet is internal. So I'm going with the internet because I want to access my applications on the browser or on the internet. And here you can see that internet facing load balancer needs a public subnet, and this is load balancer network mapping. You'll select your VPC, and here you can also see that each load balancer needs at least two availability zones, and inside that one subnet per zone. So I have these two availability zones that I'm selecting, and as you know that this is the internet public load balancer, so you really need to select the public subnets. The security group, so this is also, this requires a security group that will give the access, so that who all can access this particular load balancer even on the browser. So if I go there, let me just show you. So I will show you, okay, I will show you what this security group is, but mostly this has inbound rule which says that everyone can access this particular load balancer on port 80. There is no other configuration. You have an option even if you have a public load balancer, but you want to access it using certain IPs, you can definitely configure that. You can have the VPN IPs, so that still it is public, but it cannot be accessible outside those VPCs or VPN IPs, or even your personal IPs you can put it. So I will show you what the security group looks like. So this is where you can actually restrict who can access it. Listeners and routing. So here you will have the listener rules. And as you can see that this is where you select the default action. So for now, I'm just selecting this hello target group that I have created it. So protocol. So this is the default action. Any request goes to 80, it will go to this particular target group. You have options to create more listeners. So we are not going with the WAF and global accelerator at this point of time. And here you can see all the details and just click on create load balancer. So this will take 5 or 10 minutes before this particular load balancer is up and running. And here you can see all the details of this particular load balancer. Once it is available, this would be your DNS name that you can actually use it to access this particular load balancer. And here you can see that listeners that we have created http 80 forward to target group, hello target group. And this is the rule where you can see that this is our listener rule. It means this is the default rule right now. If no other rules applied, it will just go to target group. So right now we are just going with this default configuration, and later on I will show you how you can have a multiple listener rules as well. And based on your path filter, it will go to the target group. So before we start that, so this is one more thing that I have to show you, the security groups. So let me just so if you go to security group, and here the ECS, not ECS, ALB security group, and in this inbound rules, you can see that it has custom right now everywhere. So you have proper options. You can have just your IP, you can just have any CIDR block of your VPC ID, VPN ID, anything you can have it. Right now it is accessible by everyone. Okay, so the next part is, now let's go to ECS. So we have created this particular cluster and we have created this service. So just wanted to let you know that we have created this service without the load balancer configuration. And there is no way you can create the load balancer after you create this service. So you really need to create the new service again, which will have the load balancer configuration. So let's click on create, and this is we are providing the Fargate, no more changes in the service. And here we have a specific service like hello service. So let's go with that. And the revision 3, and the service name hello service LB rep desired task, we are going with one. You can have two also. And in the networking, I'm selecting the VPC and the subnets. In this time, I'm just selecting the private subnet because now we are using the load balancer. So once our application is deployed successfully, you can check whether it is running or not. And use an existing security group. So the security group is the same that we had before, and the load balancing. So here you can select your option application load balancer. This is your container. This information it is taking from the task definition. So just wanted to show you one thing. This is my revision where I have the port configuration. But if I select the one revision, and if the load balance, so here you can see the selected task definition does not contain any exposed port. So that means you cannot, because you are not exposing any port, so you cannot have any load balancer. So you really need to have the task definition with exposed ports so that they can be configured to use a load balancer. So this is one thing that I really wanted to tell. So now we'll just select the revision 3 and select your application load balancer, and we are using the existing one, demo LB. Create new listener or use an existing listener. We already have this, so we can just use that. And the target group also, we have one hello target group, and this is the health check pass. So you can do all this configuration and then just click on create. Okay, so now you can see in this particular service, hello service LB, our service is in running state and it is running right now. So now if we go to our EC2, basically the load balancer, where you can see like we have created this target group, hello target group. And here you can see that our register, that our target is registered here, and this is the actual IP of your Fargate instance which is running. This is the private IP, and here you can see that it is showing the healthy. So now if you go to your load balancer and get your DNS name, you should be able to access your application directly using load balancer. So here you can see that you'll get this, and if I have this particular service hello, I will get hello from hello service. So this is how basically you can configure your ECS service to use the load balancer. Now we will explore the options for the listener rules. So right now, if you open this, this is the default rule. Like if no other rules apply, it is just going to hello target group. So what we will do now, we will just create one more listener rules like this hello service and click on next, add condition, and we know our path. So our path is like slash hello, right? So we can say that if the path is slash hello, then forward to the target group, which is hello target group. And you can just have its weight also and forward to target groups. Every listener rules that you create, you have to define the priority into that, so that based on the priority rules it will get executed. So every time if it is one, it will first check this particular path filter, and based on that it will route your request. So I'm just assigning this to S1 and click next and create. So now you can see that I have created two listener rules, and let me just update this default one. So just click on this edit rule, and what we will do for the default one, basically instead of we can just have a return fixed response 503. So basically now our rule says if your path pattern is slash hello, it will go to hello target group, and if it is default, it did not save, let me just save it, return 500 target group, click on save changes, just refresh. Yeah, so now let's just try how this will work. So this should give you hello from hello service, but if I go to this, you should not see anything. You are seeing 543 error, and this is exactly the listener rules that we have defined. So how this will help now when you have a multiple microservices, and even when you have a multiple applications, and you really don't want to use the different load balancers for each of them, you can create a listener rules, and based on the path pattern or even the host header, you can just direct the traffic to the different target groups. Creating a load balancer for each of the application and the microservices is very expensive, and it is not considered as a best practice that for every application you create a new load balancer. So you can just have the listener rules for all of them, all of your microservices here. And this is very important, the rules. This is the priority rule. Based on that, your execution will always run. So whenever the request comes to this particular load balancer, it always first evaluate this listener rules. If this applies, if this is successful, so it will go to this hello target group, then it will move to the next one. So that is very important to understand that these rules when you have a multiple microservices, and even when you are just doing some branch level deployment also. So you really need to understand which request you want to go first. So that is the major advantage of the listener rules, and how you can actually redirect your traffic based on these rules. Okay, so now to understand more into the listener rules, we will be deploying one more service and see how does that look like. So for that, first we will start with the load balancer listener rule configuration. So you can just go to your load balancer and click on add rule. And here we will have word service. Click on next, add condition, and this has the same path filter. So this particular service has path slash word, and click on confirm. Next, forward to target group. So we have this word service target group that I have created. It is similar that we have created for the hello service. There is no difference in this target group. Click on next, and again you can just decide the order Right now doesn't matter, but we'll just go with the random number and click on create. So here now you can see that we have three rules in our load balancer. Now let's go to our ECS console and deploy the word service. So we'll go to our cluster and click on create and go to our service, which is word, and put the name word service, desired task networking. We'll just select the VPC here and the subnets, select the existing group, load balancer. We will be selecting the application load balancer, use existing load balancer, demo LB, use existing listener, and we are using again the existing target group and click on create. Okay, so let's just change the name of the service and click on create. So now you will see that it is creating these. Now you will see the third service is getting created. The application is running and we can go to the configuration and go to its load balancer target group. And here you can see that it is still in registration mode. It is getting registered. Soon you will see that one instance is healthy. This basically this configuration checks the health check, and if everything looks good, then it will say that yes, the instance is healthy. So yes, now you can see that it is showing healthy. Now let's go to our load balancer, get the DNS name and just run it. So this should go 543 as expected. Slash word will give you hello from word service, and slash hello you will get hello from hello service. Okay, now we will explore the concept of service discovery. So let me just go there and show you how the service discovery looks like. So if you go to your cluster, here you will find that your service is here, and if we click on the update service, there is an option called service discovery. What does that mean? So here you can see that service discovery uses Amazon Route 53 to create a namespace for your service which allow you to be discoverable by DNS. What does that mean? That if you have multiple services, then how each microservice communicate to each other, because all these IPs of these Fargate tasks are not static, they are in dynamic nature. So how two or more microservices can communicate with each other? So for that, ECS provides this feature called service discovery. So let me see how we can use it. Before that, I just wanted to show you how our code looks like. So this is like I have deployed till now. This is like sample Java application. We have deployed hello service and we have deployed word service. And this is the third service that actually communicate with hello and the word service. So how it can communicate? So here I can show you. If you go to this particular file, and here you can see that I am using this particular URL, right? So instead of using the IP, we are using some friendly DNS name which help this client service to communicate with hello service. And also one thing noted here, that this is not environment specific. I have not put any environment details there. This is simple URL. So this same Java code will work for all the environments, and you really don't need to create any environment specific property files and environment specific URLs. You can just have the constant URL that will work across all the environments. So now we will see how this particular part will work. So to understand this, AWS provides one service which is AWS Cloud Map, which you can just search here and you will get this Cloud Map service. And what does this service means? It actually define user friendly names for your cloud services so that your applications can quickly and dynamically discover them. So basically you can assign any name, any friendly DNS name to your application so that other applications can communicate with your service. So for that, what you have to do? First, you have to create a namespace, and also the pricing. So AWS Cloud Map is free to use, but yes, there is no upfront payments. You will pay as you use it. Let's create a namespace. Click on create namespace, and here, what should be the name? So here you can see that I am using this hello.corp. So corp is was my name. It could be anything. In this particular example, I'm using this. You can provide any description, and this is the API call. So I am doing this API calls and DNS queries within the VPCs. So I have deployed all the three microservices within the VPC. So using these DNS names, hello client service will be able to make a connection with the hello and the word service. So we will see, and here you have to select the VPC and TTL. This is simple like Route 53. Once you click on create namespace, it will create an entry in the Route 53. So let me just click on create namespace. So this is getting created. It will take a little bit of time before it is available. And now if I go to Route 53, okay. So now you can see that it has created this particular hosted zone corp. And here you can see this is the private and it was created by Cloud Map. And if you go there, you will just find simple NS record for this particular private hosted zone that Cloud Map has created automatically. Now let's see how we can use it. So let's go to your ECS cluster, and let's go to your service, which is Hello Service, and click on Update Service. And here we have an option of service discovery. We'll just select this option and configure namespace. So you can select your corp that we have created, or you can create it from here also. It's the same thing. And here you will provide the name of your service discovery, right? So here I am providing it hello, right? So as you can see in the example, my service name is hello. So I will just provide it hello so that it is, so this is like a friendly DNS name that you have provided for your application. You can provide any service description, and this is the DNS record. So once I click on update, it will create a Route 53 record entry for this particular service, which will point to the Fargate IP. So all things are there. Let me just click on update. Okay, so here you can see that I have created this. And you can see all the details for your service discovery here. There is a recommendation that we can use Service Connect also, but for this particular example, we are using Service Discovery. And here you can see Service Discovery endpoint hello.corp. As I showed you, this would I have provided, and this is our namespace name. And now if I look into the Route 53, so you can see one hosted zone is created, and it will create one entry for this particular new hello service as well. It will take a little bit of time, but after that you should be able to see it here. So this is how now your now your hello service can be reached within the VPC using hello.corp. So now we will just deploy the client service and see how it can communicate. So now let me just click on service, and this is the client service, and I'll just put the name client service, deployment options, rolling update. And even for this also we can just use service discovery and client, sorry, select an existing namespace corp and select an existing service discovery. No, we want to create the new one. So we'll just put the name as client, and it will also create a DNS record, and click on networking demo VPC, and we are just using the security group, ECS security group, and configure the load balancer. We already have created the load balancer, so we will just use that. Use existing listener, use an existing target group. So we have not created this, so we can actually create a new target group for this. So here you can see client target group, and there is no pattern for this client. We'll just put this slash, and that's it, and then click on create. Evaluation order, let's just do this. Okay, so now it is creating this third service. While it is creating this, let me show you the Route 53. So now you can see that it has created the third record hello.corp, and this is pointing to the Fargate IP. So now whenever you are restarting your service or anything happen to your service, this IP will change. So this will also get updated in a dynamic nature. So that is the benefit of using service discovery, so that you really don't need to put any IPs anywhere, and in an automatic way it will always point to the correct IP whenever the service restarts. So now we will just go to our EC2 load balancer and just check our listener rules, how it looks like. So if you go to this, so we have four rules right now. Hello, this, and this one is our client. We can just path pattern slash, so this will go to client. And even we can have this slash client also, but for now I am just putting it like if the path pattern is like this, it will just go to client target. Or even you can just have it if no other rules apply, instead of response code 543, because that is your main application. So you can just update this particular rule to point to the client target group, if that is also your requirement. So whatever is your requirement, you can just update it. That will point to the client target, and this client target will point to hello target and word service target using the service discovery. So now let's just see if our service is up or not. Okay. Okay, so here you can see that it failed with world.corp because we have not updated the word service yet, right? So let's just update this service also, update service, and just have the service discovery for this also, corp, and what was our name? Word service, and that's it. So this is also one good testing, that if your service you are not able to communicate, if it is not deployed successfully, then it will also fail. So this is how it's deployed, and after this is successful, then we should be able to see the client service. Okay, so now you can see that this word service is also running and this client service is also running. And let me just show you the Route 53 now.
And here you can see in this one hosted zone, then you should be seeing five. Here you can see client.corp, hello.corp, and world.corp, and both are pointing to their Fargate IP. Now we will see if we can communicate with the hello and the word service from the client service. So this is our DNS name, and as you can see, this is our rules. So it will go to client target group if there is path pattern like this. So let's go there. So here, if you click on this, you can see that we are getting the message hello from hello service and hello from service world. And if you put like simple slash hello, you will get the hello from hello service. So this is how basically the service discovery works and helps you in the ECS cluster when you are deploying it on Fargate or even on the EC2 instances. So this so this would be our final architecture diagram which we have deployed successfully, where you have application load balancer in ECS cluster. It is in the private subnet. We have client, hello, and word service using the AWS service discovery, and we have a private registry using Route 53. So this is what we have deployed successfully in this video. Thank you.